After a year during which the interest is compounded quarterly, an investment of $500 is worth $532.50. What was the effective annual rate? What I'm going to do right now is show you where that formula came from on the previous problem on the other page of the notes. So what this problem is really looking at is saying, all right, we're going to start with some initial amount, $500. The way it's compounded really doesn't matter. It doesn't matter if it's quarterly, daily, monthly, whatever the case may be. What it's saying is, given that it's been compounded and it gives you this as a net result, what would the interest rate be if it were only done one time during the year? If you were only given interest once for the year, what would that annual rate be to get the exact same result? So we'd have 500 times 1 is our 100% plus the rate for that we're looking for, and it's an annual rate, so it's only going to be R. Now note, we've done problems where I've done it as 1 plus R, and we also have done it as 1 plus R over 100. It doesn't matter which way you write it, just be consistent in the problem. Raised to the 1, because we're talking about 1 year, and this is going to equal $532.50. To solve this, it's easiest to divide by 500, so 1 plus R equals 1.065, so R equals 0.065. And that's telling us our interest rate is 6.5%. Now let's take a look at it in general. We have a starting amount, P sub 0, times 1 plus R, and we're dealing with this right now over 1 year, equals P sub t. To solve for this, divide by P sub 0. So we get R equals P sub t divided by P sub 0 minus 1. And if we have a common denominator, this would be P sub 0 over P sub 0. So we get P sub t minus P sub 0 divided by P sub 0. And that's the exact equation that we had on the other side. That is the effective annual yield, or effective annual rate. Now the only difference, what if it was over multiple years? Then we might have an exponent, or we would have an exponent here. And that's it for these notes.